How we do in algebra? Here is a video to talk about how to set up and solve some linear word problems. I know this can be one of the most difficult subjects that we come across in algebra because we not only have to solve equations, but we also have to set them up. So hopefully this video will help you out just a little bit. If you start off with a little bit of structure in what you're doing, it's always very helpful. So some steps right here for us to take a look at. Clearly defined quantities involved with common sense variables and let statements. I don't know what that means. Second one, use your let statements to write out your expressions for quantities that you are interested in. I do like this one. Okay, we can say things like let x be a number. That's a really nice thing. Carefully translate the information you are told into an equation. Yeah. And I think one thing we really got to start paying attention to is our conjunctions. So here's the Fanboys acronym to help us remember conjunctions. And conjunctions are words like for, and, nor, but, or, yet, so. And those are really important in tying sentences together. Okay, if you think about a conjunction as it holds two sentences together. And that's really important when we're translating from English to algebra. Next, we're going to solve the equation. Remember to mentally note the justification for each step. And number 5, we're going to check the reasonableness of your answer. So let's take a look at our first exercise right here. Exercise number 1. The sum of a number and 5 more than a number. But before we try to solve this, let's take a look at this picture of me and my brothers. We have over here, we have Bill. That's my oldest brother. That's Joe. And then this is me, sans beard. And if I told you that Bill is 5 years older, Bill is 5 years older than me, 5 years older. Okay. One, it's a lie. He's not actually 5. It's 4 years. But it helps the problem if it's 5 years more. We could look at mine and Bill's ages related to each other over the course of our entire lives. If I was 1, he would have to be 6. If I was 10, he would have to be 15. If I was, let's see, I'm about to be 29, and Bill is actually 33, but in this example we'll make him 34. Okay? So those are just a list of numbers that are, one is 5 more than the other. Bill is 5 years older than me. So if we go back to our question, we're looking for the sum of a number and 5 more than the number, being 17. So did any of the examples I laid out, did I add, if I add these together, does that equal 17? No for the first one, no for the second one, no for the third one. But we could keep looking. We could see that 1 and 6 only makes 7. 1 and 6 only makes 7, so we could put that there. And 10 and 15 makes 25. So maybe I go down a little bit. Maybe I try stuff like 9 plus 14. That gets me 23. Okay, a little bit lower, I'm going to jump to 7. 7 and 12 is 19. How about 6? 6 and 11, there it is, 17. Okay, so I solved the question already, but that's not the skill we want to develop. The skill we want to develop is setting up an equation. So here, let's do this. We're going to let x, these let statements I like, let x be a number. We want to find the sum of the number, and there's a conjunction, and, okay, sum told me to add, and tells me to start a new statement, and 5 more than the number is going to be x plus 5 equaling 17. Okay, and if you simplify and solve out that equation, you will get 2x plus 5 equals 17. You can subtract the 5 over. 2x equals 12. Divide 2, and you could easily find that the answer is 6. Okay? So that's just a little bit of some of the processes you want to take when you're trying to set up and solve linear word problems. And the second exercise I want to look at today with you guys is a little money problem, and we have a nice little infographic down here in the bottom left. Notorious B.I.G. told us this, that the more money we have, the more problems we come across. So if you increase money, you also increase problems. So mo money, mo problems. And let's see if we can help Kirk solve his mo money, mo problem. So Kirk has $12 less than Jim. If Jim spends half his money and Kirk spends none, then Kirk will have $2 more than Jim. How much money did they both start with? All right. this seems like an awful problem to try to figure out, but we can make it simpler for ourselves by figuring some stuff out and using some let statements. So if I look at this first statement right here, Kirk has $12 less than Jim. Is it the case that Kirk's money is defined off of Jim's, or Jim's money is defined off of Kirk's? That's the first question we need to ask ourselves. Okay, Kirk defined off of Jim, or Jim defined off of Kirk? Well, it says Kirk has $12 less than Jim, so I feel like if we knew how much money Jim had, we'd be able to answer Kirk's question. So I'm going to let Jim's money be represented by X. Okay, so then now we can make an expression for Kirk's. So Kirk, if Jim has X dollars, Kirk is going to have X minus 12. Yeah, I think we're okay with that. All right, now we can move on to the second part of the statement, which says that if Jim spends half of his money and Kirk spends none, then Kirk will have $2 more than Jim. All right, so what would be half of Jim's money? Well, half of Jim's money would be X over 2. Yeah? So if X over 2 is half of Jim's money, then we need to figure out that Kirk has $2 more than that. So $2 more than that would just be plus $2. And if we think about how all this started at the beginning of the problem, we knew what Kirk's money was, right? And then this fancy new expression over here in blue and yellow, this is Kirk's new money in the future. And what was really special, what was really specific about Kirk's money, Kirk spends none. He spends none. So if Kirk spent no money, then both of Kirk's money expressions should be equal to each other. A lot of work getting the expression set up, but now we can set up our equation and say that X minus 12 should equal X over 2 plus 2. I'm going to subtract this 2 over there. I'll get X minus 14 equals X over 2. I'm going to times 2. Times 2. Those will cancel. I will distribute in, always using my distributive property when I can, to get 2x minus 28 equals x. I'm going to subtract 2x, and I'll get negative 28 equals negative 1x, which means, final answer here, x equals 28. Okay? Now they did ask how much money did they both start with. So if x equals 28, that would mean Jim started with 28. X minus 12 then, if we subtract 12 away, means that Kirk started with 16. Okay, and if I check my answer over here, and I plug in 28 here, 28 over 2 plus 2, 28 over 2 is 14 plus 2, which is 16. I get Kirk's dollars to match. Turns out Kirk does not have a lot of problems because $16 is not that much mo money. But that looks like our answer, and not an easy one. That's why we have to be able to use expressions and equations. So thank you guys very much for watching, and I'll see you in class.